In this video of X Minute Math, we're going to look again at how to complete the square for a quadratic expression or polynomial. Now previously we looked at simpler examples and today we're going to look at slightly trickier examples. So last time we looked at completing the square for something like the following. So if I took, say, my function f of x, in particular if I took the coefficient of x squared to be 1, okay, I'll then have maybe the rest of my function. Now, last time, what we saw was, in this situation, we should treat the variable terms differently in the next line than the constant term. In fact, we'll just leave the constant term to sort of hang out and do its own thing. So what we want to do is, it all comes down to that coefficient of the x term. So in this case, the coefficient is 2. So what we do is we identify that 2 and we do a little dance with it. So the first thing we do is we half it. In this case, that gives us 1. And then we take that halved quantity and we square it. Okay, so when we square 1, we again get 1. So these are the quantities we're going to use to complete the square. We've got that coefficient of x giving us the 2. When we half that, we get the 1. And in this case, when we square that, we again get 1. So let's see how we're going to assemble those together to complete the square. So the first thing I do is I use that 1 to form a perfect square. That 1 is just going right there. And then I need to subtract the other one. Okay, so that square term, which was just another 1, that's what I need to subtract off. And then I need to remember, it's very important to not forget, that plus 5. Okay, it's just been hanging out doing its own thing, but we definitely need to include it in this calculation. So now we can just do some simple tidying. So I will get x plus 1 all squared minus 1 plus 5. That is just 4. So that's what we saw last time. Let's see what we're going to be looking at in this video. So there are 2 slight wrinkles we could introduce to this idea of completing the square. First of all, what if the x coefficient is odd or indeed a fraction? Right? Last time everything worked out, everything was a nice whole number or an integer. That's not always going to be the case. The second issue that could arise is the coefficient of my x squared term might not be 1. So I just want to throw a couple of examples at you that will show you how to handle each of these cases. So first of all, in our first example, let's take g of x to be x squared plus 5x minus 8. Well, okay, I know I'm supposed to treat the variable terms as their own thing on the next line and leave my constant term hanging out doing its thing. So what do? Well, I need to identify the coefficient of the x term, which you can see in this case is 5. So that is the quantity that I'm going to start off with, and then I will half it to get, in this case, the fraction 5 over 2. And that's the quantity that I'm going to square. So things are already getting a little messier than we've seen before. But when I square 5 over 2, I get 25 over 4. Now these quantities are going to assemble in exactly the same way as last time to help me complete the square, but the working is just going to look a little bit messier. So let's see how that's going to go. Well, I remember I used that halved term, that 5 over 2, to form my perfect square, as so. And then, oh yeah, I need to subtract off that squared quantity, 25 over 4. And then I can't forget that 8 that I'm subtracting off either. So again, I'll just tidy this up a little bit. I'll get x plus 5 over 2 all squared. And if I put those 2 constants over a common denominator, I'll subtract off 57 over 4. So you can see the process isn't all that different when we have an odd coefficient of x. It just forces us to introduce a denominator of 2 and work with some fractions. So let's see another example that will show us what we need to do when the coefficient of x squared is not 1. So in this next example, let's take h of x to be 2x squared minus 8x plus 3. Now we've got a coefficient of x squared, not 1, it's 2. All we're going to do is a little pre-step, a little step 0, and we're going to pull out that 2 as a common factor in this expression, even if it doesn't look like that helpful a thing to do. Okay, so I'm going to open up my parentheses, I'll leave behind an x squared, a minus 4x, and then gosh, that 3 is going to have to become a 3 over 2. That looks a bit hideous, but it's going to be okay. Okay, because now we've reduced to the situation we were in before, where I have my x terms and I have my constant term. There is a 2 hanging around outside multiplying those parentheses, but we're not going to let that stop us from running the process. So what do? Well, I identify that coefficient of x. In this case, that is negative 4. So I will half that quantity to get negative 2. And I will square that to get 4. So these are the quantities I'm going to use to complete the square. So let's do it, remembering that 2 hanging around outside. So I'll use my negative 2 to form that perfect square. And then I will subtract off that 4 that I got from squaring the half term. Can't forget that plus 3 over 2, it's still there, still contributing, don't want to forget about it. Now the hard work is done, we're just going to do some tidying. So I'll gather together my constant terms, I'll put them over a common denominator. Okay, in this instance I'll end up with negative 5 over 2. And now that constant coefficient of 2 out the front, that wasn't really the happiest thing to do to this expression, so let's distribute it back in and tidy things up a bit. So just multiplying, I'll get 2 times the perfect square, and I'll clear out that denominator of 2 from that fraction. And that's what we'll end up with there. Okay, I have one more example I would love to show you, and it's going to be the hairiest one yet, but we can definitely do it. So let's define p of x to be the quadratic polynomial 4x squared plus 6x minus 7. So there's a coefficient in front of my x squared, so let's factor that out, even if it doesn't look like the nicest thing to do to this quadratic. So in this case, when I pull out that common factor of 4, what I end up with is x squared plus 3 over 2x minus 7 over 4. And now I'm just going to run the same process as every other time. I have my x terms I'm going to work with. I've got my constant term I'm not going to worry about right now. And I need to identify that coefficient of x. So in this case, that is positive 3 over 2. In the next line, I'm going to assemble everything together really nicely. So that 3 over 2, I'll park it over here. Let's work with it. That is the quantity that I need to half and turn it into 3 over 4. I'll then square that fraction to get 9 over 16. Okay, and these are the two quantities I'm going to use to complete the square. My 3 over 4 and my 9 over 16. So let's put this all together, but remember that constant coefficient 4 I've pulled out the front. I'll use that 3 over 4 term to form the perfect square. I'll subtract off that 9 over 16. And then I'll remember I've got that negative 7 over 4 hanging around waiting to join the party. Hard work is done, let's just do some tidying. So inside the parentheses, I have x plus 3 over 4 all squared. If I put those two fractions over a common denominator, I get negative 37 over 16. And now I can distribute that 4 and see if that helps tidy things up a bit. So I get 4 times the perfect square, x plus 3 over 4 all squared, and then I subtract off 37 over 4. And that's all there is to it. Now if you want one more minute of math, why don't you try rewriting by completing the square the following. Q of x equals negative 2x squared plus 3x plus 1. And if you'd like to do X minutes of math Y more times, don't forget to subscribe to this channel.